This lesson involves the start of making a representative model of an iconic cathedral in Brazil. The Cathedral Brasília is a hyperboloid structure constructed from 16 hyperbolic concrete columns. Part 1, we are going to make the frame, and we are going to focus on the use of the conic and block commands. Create a new part and save it in a new folder called Cathedral Brasília. Name the part Cathedral Brasília frame. Change the units from millimeter gram second to meter kilogram second. Create a reference plane 26 meters above the top plane. Press F on your keyboard to view the plane. Sketch a circle, dimension it 17 meters, and make for construction. Using the segment command, select the circle as your parameter with 16 sketch segments. Using the midpoint line command, draw a midpoint line from the center of this segment to the center of the circle and make for construction. Exit the sketch. We have now created the throat circle for the hyperboloid. We now have to create the hyperbolic sketch path. Create a plane using the midpoint line and the top plane as your references. On this plane, we are going to create the following sketch. All lines will be center lines from the origin horizontally and vertically, and from the center of the circle. Dimension the bottom line 30 meters as well as the top. Dimension the distance for the top line to be 26 meters above. If you want to hide that second plane, do so to make it more easy to see the lines. We are now going to select the conic command, which is underneath the ellipse, and first you select the ends of the 30 meter sketch lines. You can see that the conic can be drawn either side now. We select the center line as the vertex and the row. The row value is to determine whether it's a conic parabola, hyperbola, or ellipse. Accept that. We are now going to fully define it by first making the vertex coincident with the circle. and then dimensioning the x value 3.1 meters. You can see the conic is now fully defined. If we select the conic and show the parameters, we can see the rho value as 0.799. This means it is a hyperbola. Anything above 0.5 is a hyperbola. Exit the sketch. We are now going to create the loft profile sketches for the hyperboloid. To do this, we need to create another plane above plane 1 that contains that center line. Select the line and the plane as your references, making sure they are parallel. On the plane that contains the circle, we are going to sketch the following profile. Using the Convert Entities command, we can select the segment and convert it and draw 2 lines to complete the profile. We dimension it 2.5 meters and you can see it's now fully defined. We are going to use this profile sketch again on the top and bottom of the hyperbolic path, and to do that we are going to make a block for the top and the bottom. Go to Tools, Block and Make. We select the 3 lines as the block and the insertion point as the center of the arc portion. We can now exit that sketch. On the top plane, we can create a sketch and we can insert the block that we're after creating using the insertion point to the center coincident with the end of the hyperbola. We change the scale to 0.5. We do the same on the very top plane. If we exit that sketch, create a sketch on the top plane, go to Tools, Blocks and Insert, and insert it in the same method, and change the scale to 0.5. We can exit that sketch. We now have 3 profiles and a path to create a loft for the hyperbolic shape. Select the loft command. Select the profiles as the 3 sketches, as we can see, and the guide curve as the hyperbolic path. accept that. And that is the hyperbolic shape for one of the concrete forms. On the top plane, we are going to sketch a base circle that is coincident with the outside of the path and also the inside of the path. We are going to extrude that 0.1 meters. We can hide these planes to see the remainder of the exercise a little bit more clear. We are going to create a circular pattern and use the feature loft 1. The center of rotation, we can use the sketch that we created earlier that has the center axis. We need 16 equal spaces, 360 degrees. When we accept that, we have the 16 parabolic shapes together, as we can see. We now need to cut with the surface to remove the upper portion. So we insert a plane (40 meters) above the top plane. We use the cut with surface command to remove the upper portion. Ensure that the arrow is pointing upwards, and we remove the upper portion, as you can see. Again, we can hide that plane. Our last job is to chamfer the tops of the structures. I'm going to select the chamfer command, and we're going to give it a distance of 1 meter, 10 degrees, and ensure flip direction is selected. If we select the top surface, we can see that each one will be chamfered as shown. The cathedral frame is now complete.